Hello everyone, myself Vignesh Anand. Welcome to my channel. In this video, we are going to see about the current transformer. Normally, current transformer is a instrumentation transformer, which means it measures the current flowing in a path, which means it may be a bus, it may be a line, or even it may be some feeders or anything. So the main purpose is that it measures the current, and then the measured current will be given to your metering or even in your protection. Likewise, we can use in a the measured current will be given to your metering equipment like a meter or a multifunction meters, or it may be used in a protection device like earth fault relays, overcurrent relays, then differential relays. So protection wise we can use it, and also we can use it by metering wise also. So a CT is an instrument transformer used along a measuring or a protective device in which the secondary current is proportional to primary current and differs from its by an angle that approximately 0. So the basic principle of a CT is same as like a power transformer, which is whenever the alternating current flows through the primary winding, alternating magnetic flux is produced, which then induces an alternating current in a secondary winding. Normally, the CT comprises of primary and secondary windings. So, in the sense, whenever the current flowing in a primary winding of the CT, it will make some fluxes, and that fluxes which induce the alternating current in the secondary side of your winding, which means secondary side of your transformer. And the secondary side of your transformer are connected to your metering or protective devices. Normally, the primary current is a, which means the primary winding is a large current measuring thing, which means the primary side of your CT is connected to directly to your equipment, which means your primary equipment of your substation. So in the sense, the large amount of current will be flowing in your primary side, and the secondary which is having a very less amount of current, which means in most of the cities you may have only 1 amps or 5 amps of your total secondary current. So this is a standard thing, which means in a secondary side of your CT will have 1 amps only. Even the primary side may be a 4000 amps or 5000 amps also. The secondary side will be a 1 amps only. According to that, the turns ratios will be calculated, and according to this, the manufacturing thing will be done. So your secondary side is a nominal as a 1 amps or a 5 amps. Some of the cities will have a 1.5 amps or a 2.5 amps, likewise 3 amps, likewise. So the secondary side will have a, most of the cities will have a 1 amps or a 5 amps only. As I said, the CT basically consists of a iron core upon a primary and secondary winding are wounded. The primary winding of a CT is connected in a series with the load, which means the primary side of your winding of your CT is connected in series connection with the equipments. Then the secondary side is connected to your measure protective relays as per the device configuration, or as per the star pointing or a delta pointing wise, the CTs will be connected. Then the secondary current is represented as a 1 amps or a 5 amps. Then they should not be disconnected from its rated burden while current is flowing in a primary, as the primary current is independent of a secondary current. Then it acts as a magnetizing current when secondary is opened. This results in a deep saturation of core. In here, what they have said is that the while at the time of load, which means while at the time of primary side is having a, for example, I'm saying for a 4000 per 1 amp CT, in the sense 4000 amps in a primary side, and 1 amps will be in a secondary side. So whenever the current or the line is energized, or even the feeder is energized, the primary side will have a load, which means, for example, I'm saying there is a 2000 amps is running in the load. In the secondary side will have a zero point 0.5 amps, which means, for example, I'm saying for a 4000 amp CT, 2000 is now load. So our secondary side is 1 amps maximum. In that, half the amount in the cells, zero point 0.5 amps will be running. In this time of condition, the secondary side should be in a closed manner, or else it should be star pointed and earthed. One side will be, one of the end will be earthed. If in case, in any problematic cases, if your secondary side is get opened, means automatically the primary side, which is not dependent on the secondary side, so automatically the secondary side is opened, means it will act like an magnetizing curve, or like an high voltage will be flowed in that path, which means whenever the a closed circuit get opened, means automatically the voltage get built up in that. So in the sense, it will cause your CT to damage, or even that particular core, or even that whole CT will get saturated due to this condition. So always a CT should be in a closed manner, or a star pointed, and then used for a protection or metering devices. So even a spare course, which means the not used course of your CTs, also should be in a short circuited, or in the sense, it should be in a closed manner. It should not get opened in any of the cases, because it will cause your saturation of your core also. Even it will leads to your failure of your CT. So always keep in the mind that the CT should be in a closed circuit. It should not be in an open circuit. Next is your accuracy class of CT, which means normally in the specification of your CT itself, they will mention as a the accuracy class is metering else, or a protection special core, or a protection core, or a 5P15 or 5P20 type of protection cores. In the sense, what they are telling is that the metering core, in the sense, you should use only for the metering purpose, which means for the ammeters, or multifunction meters, or energy meters. Such a way you should use it. The maximum permissible current error at a rated current, which means it will be in the metering classes will be in a class of zero point 0.1, zero point 0.2, or 0.5, 1%. Like it will be mentioned in that metering core itself. The error should not exceeds this value, as per mentioned in the specification details. Because the metering core, in the sense, it has a very less amount of a burden. So if we wrongly use this metering core for a protection core, means whenever the large current or fault current flows, automatically your core gets saturated in the sense, the voltage, the current will not get higher, and also the voltage level will be higher, which means the current will be in a saturated level. There will be not maximizing the current level whenever the overload or fault current get induced. So the metering core should be used for the metering purposes only. Next thing is that protection special core, or a PS class, which means in the specification itself they will mention as a protection core as a P, indicating as a P, or PS, protection special class. So in the sense, it should be used for any type of relays protections, like differential relays, distance relays, or overcurrent earth fault relays, or impedance relays, or a restricted earth fault relays. So it should be used in a relays kind of cases only. The protection special class should be used. Next is 5P15, 5P20. Normally you can see in our specification itself, the accuracy class will be having some kind of 5P15, 5P10, 5P15, 10P15, 10P20 likewise. So in this case, this is also a kind of protection class of CTs only, but it will be used for your earth fault relays, overcurrent relays, then impedance type of relays. For these cases, this relays will be used. So mainly the thing is that the first number 5, in the sense it denotes the percentage of error, 5% of your total burden. Next, between word p in the sense production class. Then last, it will be mentioned as a 20, 10, 15. For example, I have written as a 5p10. So 5p10 and 5p20. In this case, I have taken of 20 in the last name as a 20, in the sense accuracy limit factor, which indicates the CT will sense with a 20 or a 10 times of its secondary current flows, which means whenever the fault current is increasing more than 10 times of your nominal current value, means in these cases also the fault values will be measured by the CTs or sensed by the CTs without any failure. So these and all the accuracy classes commonly used. Next, types of errors: current or ratio error, phase differential error, and composite error. Next is basic types of CT. There are three basic types of CTs, which means common uh, installation basics are wound type of CT, toroidal or terrestrial or window type of CT, then bar type of CT. In this, wound type is a transformer, which means the CT primary winding is physically connected in series with the loads or anything with the conductor that carries the measured current flowing in the circuit. So the magnitude of secondary current is depend on the turns ratio of this transformer, which means the CT. Next, the terrestrial or a window type of CT. This type of CT does not contains any primary winding. Instead, the line that carries the current flow is threaded through a window or a hole in the CTs, which means in here there is no such a thing as a primary winding. Instead, there will be the holes will be there in the CT. In that hole, the line will be going inside and coming outside. So in this way, the line which going inside and coming outside, that will act as a primary core, which means that will act as a primary, and surrounded by this secondary, the turns will calculate the or measures the current. Next thing is the bar type of CT. This type of CT actually uh, a cable or a bus bar of a main circuit as a primary winding. It consists of a bus bar as a primary winding. They are fully insulated from the higher operating voltage or, of a system, and are bolted to the current carrying devices. So these are all the three basic types of CTs used in the substations, or even in your any of the instrument stations also. Like small instruments also having some of the CTs for measuring the currents. Next thing is that types of, which means testings use to ensure the CT healthiness. So in normally in substation, these testings will be carried out, which means the insulation resistance test, knee point voltage test, or magnetizing current curve test. Next, polarity test. Next, current ratio test. Next, tan delta testing. Next, winding distance testing. These are all the basics testings carried out in a substation for for checking the healthiness of your CTs. So in coming up slides, we will see the basic examples of your CT physically. This is the common basics of your bot type CT, which means the physical thing. In here there is a two screws you can able to see, I think so. That is your secondary side. It will be mentioned as a S1 and S2. Then between that there is a hole inside your CT, that line will go inside and come outside, which means the feeders will go inside and outside. This is your terrestrial current transformer. This is a splitting type of terrestrial current transformer, which means you don't need to remove the installation things and all. You can plug in and plug out type of CT is this. So easily it can be plugged in and plugged out whenever there is any shutdown or anything you need to do. So this is your basics of your CT. In each I have mentioned that first is the point number one is the oil volume compensating system. Second is the oil level indicator. Third one is the primary terminal. Fourth is your coarse and secondary windings. Fifth is your primary winding. Sixth is your secondary conductor. Seventh is your insulator, which means porcelain or a silicon rubber. Eighth is your capacitive bushing. Ninth is your refined ground connection, and tenth is your oil sampling valves. So this is the basics connections, which means basic things in your city. Gas before used one is your uh, line type or oil type city. This is gas type. The gas evacuations, next high terminal voltages, which means the line feeders. Third thing is your magnetic core and winding inside the houses, which means the inside there will be a magnetic core and windings secondary for primary and secondary winding will be placed, and outside will be covered by your porcelain, and bottom will be your secondary terminal box. So this is the live tank, which means oil type of your CT. The primary P1 and P2 are mentioned, and secondary side bottom S1 S2, then 1S1 1S2 2S1 2S2, in the sense core 1 will mentioned as a 1S1 and 1S2, and core 2 will be mentioned as a 2S1 and 2S2. This is your secondary terminal box at the bottom, and the oil tank will be surrounded in the primary side. Between portion will be having a core, which means winding, insulated windings, and outside covered by a porcelain or a rubber covers, which means silicon rubbers insulating. And also some of the examples of CTs I will mention. This is a 33 kV CT. As I said, the two side of your bar will mentioned as a primary P1 and P2 at the top, and surrounded by the oil tank. uh, and between portion will be your porcelain, in here used as a porcelain, and bottom will having a secondary terminal box, and the valves, oil valves also been I have mentioned here. This is your valves, which means oil valves. From this you can fill the valves, top of the valves. This is the valve indicator, oil level indicator. uh, the maximum minimum level of oil will be mentioned in the glass plates, and also we can able to monitor in a regular manner, so that we can easily able to know if any leakages or minimum level of oil will be easily mentioned or easily known. This is your nameplate details of your this 33 kVCT. So as I said, primary P1 and P2 at the top, and at this bottom secondary S1, which means 1S1 1S2 2S1 2S2 as mentioned. In here we have a core, two cores. One is your 1S1 1S2, and another one is your 2S1 and 2S2. Here both the cores are zero point 0.5 class, which means zero point 0.5, and also a 5p class of 5p20, 5p20 ALP factor. ALP matlab accuracy limit factor. So this both the cores are used as a 5p20 classes of AC. So as I mentioned, 5 in the sense 5% of error. Both are as protection, both are protection cores. So 5% of error protection core, and 20 in the sense 20 times of burden, which means 20 times of your rated voltage, rated current will be measured in the time of fault. So I will just read out the what specifications. Highest system voltage is 24 kV. uh, the installation level is 50 kV, and frequency is 50 hertz. Diagram number I don't know it. CT ratio is 200 per 1 amps. Secondary core is 200 200 matlab primary side 200 and secondary side 1 amps. Next, rated primary current 200 amps. Next, maximum transient current or a time to CZ 180 kA per 17 UE. Quality of oil is 20 liters approximately. So these are all the basics which is mentioned in your nameplate, and also uh, in here this is both are primary, which means production type, of course. In coming up slides we will see the other type of cities like production metering, and also it is a 200 amp city. So in future, if possible, I will mention any of the 4000 or 2000 amps of cities in coming up slides. Hope you understand. I think so. Share your knowledge and gain your knowledge. Thanks everyone. Nandri Vanakkam.